Assalamualaikum and welcome to my channel. Today we would be studying about uh, making calculator using Arduino and also in assembly language code. We would be seeing it in Proteus as well as in my Atmel Studio. So first of all, there's an I've written C++ code over here. As you can see over here, it's a lengthy code, but it works. So, and in the Proteus, you can see this is a calculator that I've attached. With it, there's an IC MX746C922. This is used to interference of this calculator. Used for the interference of this calculator. So if you have just play it, when I said 1 7, so this power portion would just be there for declaring that whether a value is added on it or not. Like I just go for this, and you can see the LEDs opening says this tells us that if there is a value added into it or not. Okay, so after this is over here my BCD segment just to tell that what is going inside it, and then this is the main result file. So let's start with the program. So when my program is that when LTI, I simply this is just written just a general program of telling the what is the input and what way would be the input be done and where would be the output be done. And then this is the code ahead. So first of all, I've declared two resistors, that is LDI R17 and LDI R28. And then in the input of I've added of LDI R28, I've added the input of resistor 28 from the pin D. Then I have declare to. So I've called the function declare to. Declare to. Okay, here it is. So in this declare to, it what it would be doing, it would just be checking the what is the number value of R28. If it is from any of this, it would simply what it would do would it would be that it would simply go to the R28 and check its value and then come back to it. 28, it will simply go and check its value and then put out the function. So here first of all I would also be telling you how to make a program. So this I just open my Proteus the 8.10, and then usually this button is connected, but you should press this button and select Arduino, whatever your Arduino is. Mine is Arduino 328, so I'll just go and finished. So what would I be doing here? This is the generically this is displayed over here. I'll simply go and okay. What I'll do is simply I need these pins. I don't need these pins. I'll just simply delete them. Whatever I wouldn't be needing, I'll simply delete them. So I'll simply delete this. Then I'll be deleting these pins because I do not need them. I'll simply delete. And then what I would be doing, I'll simply copy, drag. Okay, drag. And then I want this to change to opposite. Okay. So, this is my pin code B. I'll simply be going to calculator, keypad calculator. So keypad, keypad calculator, and this is it. This is a small calculator. Then also with it, I'd be needing mm. Okay, I will be needing this one. I see. I'll be showing you here. ICMM 744 C922. So I'll simply go and paste over here, and here it is. Then I also need 7 segment display. display. Seven segment I would take blue and one blue. Okay. So what would I simply be doing over here would be one this and where's my keypad. Okay, over here this delete and attach it once I'm done with it. So okay, this is a little bit far away. So two VCDs, okay, the green ones will be attached over here, and then I'll go to the MC for my. Okay. So I'll be pushing them a little bit. Okay, so we have to attach it like this. Okay, so we have to attach it like this. Okay. So this will be attached to Y and this will be X. So um, I'll go to. They need to use circuit complete the more you will best you can understand. So as you can see here, so what I will simply do here. Now I have to name them. So I'll be attaching the file of it. It is saved in my C drive users, everything, documents, administrative, file, file, folder, it is not okay, so there's a gray voltage coming over here, even over here. So for this, I have to add this part. There is a oh, and then I'm really copying it. Copy the clipboard from here. So that's why this is the reason. Uh, this okay. So sorry. Please stop it. That usually this is the reason add this over here because most of the time this does not works without it. So sorry. But somebody be doing this and I need a ground over there. I placed it up because I have a ground over here. And what I would be doing is let's start now. I hope this works. It's still not getting answer. So in the previous one, but still I can explain you how to do it. Okay, I also need one more binary segment, and that would be hey. I think that should be okay. This would be giving us answers. Go back to the pins. some connection issue because this circuit was completely working before, so maybe, but I think this would help us. See, eight, oh, seven, yes. So in my this is seven, and I have to find the B. Okay, so this is a B. So if I go 7 minus 6, so equals to 1. So this is showing us 7 cross minus 6 is equals to 1. This is a 4-bit calculator, so it is showing like this. Now in over here I have made the same one but in a different manner. And this also shows the result. But in this, when the value is 0, it would be giving 0 0. And then eventually it would be changing over here. Okay. Now explaining the code to you. So first of all, in this I've done what I have done is an easy stuff. First of all, I have taken the starting one. After the starting one, I've declared the both of my LEDs that I would be using ahead in my solving it, and then I declared that second input value, and then what would happen then when once this value is done, I'll simply be skipping to R2 called declare 2. So declare 2 is over. Okay. So if the value is equals to 1, then it would compare subtract R28 value and R20 value, R20 R18 value, and if both are equal to 0, this will go break into 1. And what is on the 1 1 function? One function, it is that if the value I would implement the value of R21, R19 is equal to 001. So, and it would copy the value of R19 to R28. And more value is for the copying value, and then it would determine jump to determine value. What is determine? Determine is over here. In this determine function, I have called in a register R21 as pin D, and what I've done is that if its R21 value is 00F, then what would happen? It would subtract R20 and R21 and be equivalent to addition. Of if the value of R21 is BRE, uh, the value of entered is R20, then it would simply skip to R20F. Okay, and it would go to subtract value, and so if it's 0, then it would run to the function addition, or if it is not equal to say 0, then it will proceed to the in value of 21 to VR 0 0b in value. Okay, so this is in LDI value. LDI, sorry for this mistake. I can again run the circuit and so anything added to F would always be giving us this number, because this is a 4-bit the calculator, it is giving a very high value. So it is working auto. Okay, so in this after that it is would be skipping to we were here over here, and if it is b0 of b the hex value 00 cross 0p, then it would be skipping to the subtraction function first, the addition function. In addition function, LDI at R29 is equal to 0. I had to add BR equivalent. Sorry. Uh, I added it if the distance value of R17 is 0, then it will turn to new. But if its value is already entered, then it will add R21, R28 to R17, and its output port would be displayed on a port B, and then R28 would be displayed. This is I call these three their delay functions. So because this value happens so fast that it does not tell you how what's the result is, and it simply converts back to its value. In this subtraction, I've done simple subtraction function. This was my